Hi, I'm Ruban, son of Anandan, and my metric number is 172070025. Today I'll be sharing about how to make NaCl crystal. Let's jump right in. NaCl is the chemical formula for sodium chloride, also known as table salt. It is a crystalline solid with a cubic structure and is composed of equal number of sodium and chloride ions arranged in a regular pattern. The ions are held together in the crystal lattice by strong electrostatic forces, and the crystal is held together by van der Waals forces. The structure of the NaCl crystal is often used as a model for understanding the properties of other ionic compounds. NaCl is a common household chemical and is used in many industrial and medical applications. There are several methods that can be used to prepare NaCl crystals. Here's a simple procedure for preparing a saturated solution of NaCl that can be used to grow crystals. First, dissolve a measured amount of NaCl in a small amount of hot water in a beaker or other suitable container. The amount of NaCl used should be slightly more than the amount that can be dissolved in the water at that temperature to create a saturated solution. Stir the solution until all of the NaCl has dissolved. Allow the solution to cool to room temperature. As the solution cools, the excess NaCl will begin to crystallize out of the solution. Once the solution has cooled, carefully pour it into a clean and dry container, such as a petri dish or crystallization dish. Place the container in a cool, dry place and allow the crystal to grow undisturbed for a few days. The longer the crystal are allowed to grow, the larger they will become. Once the crystal has reached the desired size, carefully remove them from the container and allow them to dry completely before handling. Keep in mind that this is just one method for preparing NaCl crystal, and there are many other methods that can be used as well. The exact procedure may vary depending on the specific requirement of the application. In this case, the crystal doesn't form properly due to impurities in the sea salt and tap water which is used, and possibly due to changes in temperature and sudden vibration which might have disturbed the crystal growth. NaCl or sodium chloride is a type of ionic crystal with a cubic crystal structure. This means that the atoms in the NaCl crystal are arranged in a repeating pattern in three dimensions, with each atom surrounded by its six nearest neighbor in a cubic arrangement. The cubic crystal structure of NaCl is known as a face-centered cubic or FCC structure. In this structure, each sodium atom is surrounded by four chloride ions, and each chloride ion is surrounded by four sodium atoms. The FCC structure is held together by strong ionic bonds between the positive sodium ions, and the negative chloride ions. Overall, the cubic crystal structure of NaCl is characterized by a regular repeating pattern of ions that extend in all three-dimensional space. This gives the crystal its characteristic properties such as its high melting point, electrical conductivity, and the ability to dissolve in water. Crystallization is the process by which a solid forms into a crystal structure, which is a repeating three-dimensional arrangement of atoms or molecules. The process of crystallization occurs when a material is cooled or pressurized to a point where the atoms or molecules become arranged in a highly ordered repeating pattern. Crystallization is driven by the desire of atoms or molecules to minimize their energy. When a material is in liquid or in gas phase, the atom or molecule have a lot of energy and are free to move around. As the material is cooled or pressurized, the atom or molecule slows down and starts to interact more with each other. At a certain point, the atom or molecule will start to rearrange themselves in a way that minimizes their energy, forming a crystal structure. The specific crystal structure that the material will form depends on the nature of the atom or molecule and their interaction with each other. For example, in a metallic crystal, the atoms are held together by a sea of valence electrons that are free to move around through the structure. In an ionic crystal, the atoms are held together by electrostatic attraction between the positive and negative ions. In a covalent crystal, the atoms are held together by covalent bonds, in which the atoms share electrons. The study of crystallization and crystal structure is known as solid-state theory, which is a branch of condensed matter physics that deals with the physical properties of solid materials. Solid-state theory helps us to understand the behavior of materials at the atomic level and predict how they will behave under different conditions. Solid-state theory is a branch of condensed matter physics that deals with the behavior of solid materials, including solids with long-range order, like crystals, and those with short-range order, like glasses. It is based on the principle of quantum mechanics and statistical mechanics, and it is used to understand the electronic, optical, magnetic, and mechanical properties of solids. In solid-state theory, the behavior of material is described using concepts such as lattice, which is uh, an arrangement of atoms or molecules in a repeating pattern. The properties of a solid are determined by the arrangement of atoms in the lattice as well as interactions between the atoms and their electrons. Solid state theory is used to describe how this interaction gives rise to the various properties of solids, such as electrical conductivity, thermal conductivity, and optical properties. That's all for today. Thank you.